Fryderyk, co-founder of Zeta Labs. And me and Peter, my co-founder, today will speak about the job replacement, the future of job replacement, and how we see agents in there. I will start with a vision, and then Peter will tell you a bit more how you can contribute to that by building agents on your own. Cool. So let me start with asking you a question. If you could hire a reliable autonomous browser agent today, let's assume that it's fully reliable and very fast. What tasks would you want to have replaced? I need 3 tasks.
Boring ones.
Yeah. Travel organization, yeah.
Expenses.
Expenses, that's cool. Yeah.
Calendar.
Calendar. I love the calendar one. Cool. I think if you have a reliable agent and you want it to behave as your employee, our claim is that sometimes you don't want to prompt the agent. Just like when you hire a good employee to your company, you spend some time on the onboarding, initial training, but after that, if it's a good employee, it's very independent, you don't need to ask them to do things, right? So you can expect them to come up with the tasks on their own, and you probably shouldn't expect them to ask you every day what should be done. You don't want to overlook everything that's being done, and you want the employee to come up with the tasks on their own. Ideally, you just give them the vision, and they will do the rest. The question is how we can implement this into agents. Probably, this is not the right UI for this. In this UI, you just prompt the agent to do things for you one-off. I think it's great for demos and for showing the capabilities of the agents, like demo drives. But I don't think this is what the future looks like. So the question we can ask ourselves is how to embed agents into our workflows. I think a good place to start is asking ourselves what are the high leverage activities that we want to preserve in our daily life and what's noise. I will give you an example. In a founder's role, a very high leverage activity is hiring. Of course, if I hire a team of 10 people, they can do the job for me 10 times better than me because I hired smarter people, and it's a huge leverage. However, this huge leverage is surrounded by a lot of noise. For example, setting up meetings or searching for them on LinkedIn. So I think the vision that we can keep in mind when building agents and thinking about how we can embed them into our workflows is how to distill the high leverage activities and preserve them for ourselves while outsourcing the low leverage things for agents. One solution right now is just to, like, if you're a big company and a big founder, you can hire an executive assistant that will do the meetings for you and set up those things. You probably need to give them a big salary, like a 50, 70K or something. But initially, you always start with a problem. It's not like you look for an executive assistant. You start with a problem. Hey, I need to set up meetings, and I don't have a very specific need for all the surrounding skills that they have. So instead of hiring, how about we just hire agents to do just this one thing? I think if we find a way to implement agents in this way, that would be truly revolutionary. So for example, here, if we build a simple agent today, if you use our agent, Jace, go to Jace AI and use our agent, you can just CC Jace into your emails and it will do the meeting setup for you. Super simple, doesn't need to interact with browsers, tools, anything. Needs to know your calendar and needs to have access to your availability. That's it. So as you can see, I see Jace. Jace is replying to an investor interested in Zeta Labs and setting up a meeting for me, knowing my availability. That's sweet, but most of our tasks require integrations and tool access, right? I think in order to think about how we can enable those integrations, we can distinguish 2 modes of human work. One is reactive, and the other one is proactive. A great example of a reactive job is a customer support. What happens in customer support is that when you get an email for example, asking for a refund, you do a very well-defined task. So what you do is you go to your logging system or whatever, you see whether someone used the app or not, and based on that, you can give them a refund or not. And that's pretty simple. You need to attach Stripe, the agent can do the refund and everything. And then there are those proactive jobs, like for example, a founder's job, where it's super difficult to describe what needs to be done by a simple set of rules, right? However, we still think that in every job, even in founder's job, there is the reactive layer that still creates the noise and ideally would be handled for us. So let's focus on the reactive part. We think that the reactive jobs will go first. The beauty of the reactive things is that once you set the rules for the agent, once you go about do the initial training, you don't need to prompt the agents anymore. They will just follow the rules and do everything for you. But once the complexity comes in, it can be more difficult. Of course, agents as of today can perform reliably, I think, hundreds, up to 1,000 steps, but it's more, we can't really trust them yet. So we have to be careful. Okay, so we talked about the reactive bit and the proactive bit. I think the first step to implementing the reactive job replacement by agents is to create a pool of triggers, the triggers that cause the reactions of agents. Once you have the pool and the agents know the rules by which they should pick up tasks and perform the actions, the agents then can, like the pool being, for example, the Slack messages, emails, or phone calls, the agents can pick up the tasks, suggest solutions for you, do some upfront work in the browser, and then just show you, hey, do you want me to perform this action? And then you can just approve. So we went from prompting agents to do things, to manage our calendars, to agents doing this on their own. I think we all know that everything is a reaction. In particular, like even founders' job is about reacting to things like macro market movements, things that are rather unusual, and there are not many templates to being a founder as opposed to, for example, being in customer support. However, the more descriptive our rule set is, the more proactive jobs we'll be able to replace. And as we extend the rule set for reacting to the triggers, I think we'll go closer and closer to replacing the proactive jobs. So assume that we have built the meta aggregator of all the triggers that is being, macro movements of the market, as well as, emails, phone calls, Slack messages, linear issues, whatever triggers our actions. I think the continuous improvement of the foundation models and their cognitive abilities going up will allow us to have a very complex rule set, because those models will be able to reason just like humans in terms of performing their jobs and deciding on what's next. But the question is how to build this aggregator. And I think a very simple way to start would be, for example, in linear or in Slack, and then agents just picking up tasks and performing them. But then once we build the aggregator, the next step is to make the agents act. And browsers, as opposed to APIs, allow us for very generic actions. APIs are very often limited and not really well implemented. So if we can make the browser agents work, can we fully replace humans at their jobs? I will pass now to Peter, and Peter will tell you how you can implement browser agents today to reliably perform your daily jobs, and what are the challenges on the way.
So, hi, I'm Peter. I previously worked on the Llama 2 models at Meta, and like Fryderyk said, I'll give you a bit more actionable insights on how to actually build agents and kind of what the steps are you need to go through there. So I think like if you want to build any kind of LLM part in your system, and especially for agents, you go through a few different steps of based on the complexity of your task and how much performance you want to have. And basically, this is kind of separate for every single system you have. You usually can start up with prompting, and once things get more complex, you add cognitive architectures. You can add fine-tuning and reinforcement learning. But I would kind of go through each of the steps separately, because each of these kind of reduces your iteration speed a lot. So with prompting cognitive architectures, you can do things within hours. Fine-tuning reinforcement learning is more like a week to monthly projects, and any kind of changes you want to make basically slow everything down a lot. But if you kind of need to go on a certain task to really high performance, you kind of have to go also through steps. So first steps are some general ideas about how to improve your prompting. So usually it's a good idea to kind of rewrite your prompts with language models itself, because you kind of use the lower perplexity text that you give to a model. So also you can have your own misunderstandings that you had initially will kind of be taken out. We'll also try to use XML syntax, Anthropic kind of started with this for their prompts, but I think it's useful for any model, just to separate instructions from content. Also, some useful mindset is to always try to match the fine-tuning and pre-trained distribution of your language model. So if you use GPT-4, you kind of have to think about what did OpenAI probably fine-tune their models with, and also what is kind of in there. So, for example, you should probably prefer JSON or XML or Markdown, unified diff format when trying to output text, just because it's more frequent in pre-trained distribution. So if you shouldn't probably introduce your own format or your kind of own syntax to do things. You want to do things just like the most likely to appear in the web. It's also similar for what you put in the system prompt versus user prompt. If you decide to split up things into multiple messages or just one, just have to think about what probably OpenAI got in their fine-tuning data set, what most people do, and that's usually a good way to stay within the distribution of the fine-tuning, and will give you better performance. Also, you should kind of try to think of how to minimize computation at each token. So if you have a complex task, one thing is to keep in mind that if you want to output, for example, mappings, like element ID 5 or 4, you usually want to prefer text values. So if your model can output text, it's better than specific numbers. And because basically you're skipping one mapping step. So you should try to let the model only reason about one thing at a time. It's also relevant, if you do classification, for example. It's better to first classify things into broader categories and smaller ones, instead of directly going to the smallest one. And if you do this, it will just improve performance in general. I would also, if you have some idea about how to think about a problem, I would try to give you, if you do chain of thought, I wouldn't just say let's think step by step, but instead you should kind of think about how you would approach a problem, and specifically add these things in your chain of thought. So, for example, first thinking about summarizing the problem you have, and going for all the steps. A few more ideas is that you should think about everything that you put in a prompt is basically noise, and some valuable content in there. So if you can reduce the noise as much as possible, and only have the most relevant context in there, the model doesn't need to find out what is noise and what is real context. For featured examples, some really useful tips is that you shouldn't probably, if you have really long inputs and really long featured examples, you don't have to show the full ones. You just only focus on the few most important parts of them. And the model will still usually capture kind of how things work. Also, even once you start prompting, you want to already set up some, maybe 10, 20 examples to kind of always run each prompt through. Additionally, to have some better end-to-end evals as well. So once you kind of exhausted all the gains you kind of get with prompting, you can try to split up tasks into multiple pieces. So basically, you can think about how much cognitive load you put on a model with one prompt, and if you can split things up further, and also if you have some preconceived notion about how the problem should work, you can kind of improve this. So a few ideas about this is kind of that you add explicit state tracking of if you have a longer task, you basically keep track of the state that the task currently is in. This basically increases the quality of context you kind of giving your model. Here's some ideas, for example, of using kind of planning. You kind of generate plans, afterwards modify them, replan. You can also have the verification steps afterwards. Or you kind of take notes or have a scratch pad for intermediate work. But once you kind of split up things in multiple pieces, then latency becomes more of an issue. So there are often good ways to kind of parallelize the work while still kind of getting good performance. Also, for all of these kind of agents, it's really important to think about really natural interfaces for them to use tools. So For example, we found that if you want to update state, like for example, some nodes you have, it's often good to address them like with key value updates. Because basically you're kind of mimicking a Python syntax, you kind of update some dictionary, and this kind of allows you to target elements really well. Because the model only needs to think about the key, and then afterwards can think about what to update, and not do both things at the same time. You can get even better performance usually with most models if you do full rewrites of what you kind of want to update, because this gives the model even more time to think about things, but when you add more latency. So I think that's, for example, why you see in Cursor like all the text rewritten, because currently both best models are not that good at generating like small diffs. Also, you should try to avoid any recursive nested structures if you can. This will just, like the more nested it is, will just be more out of distribution and make it more complex for a model. Yeah, also you can kind of use some reasoning templates. Like if you know how the problems are structured, you should also kind of reflect this in the prompt. If you deal with images, then one good idea is that you try to move the reasoning into your text. So you first describe the key points in your image, like you let model output the text form, what the image contains, and then afterwards reason about this. Just because the models have been trained on trillions of tokens in text, and most of these image language pairs are usually much less data. So if you do reasoning about images, it usually performs worse than if you first convert it into text and then afterwards into more text. You should also think about how to design your components to correct for one part, if you have one part in the system that creates an error that another handles it. And the more cognitive components you kind of add, the more brittleness you also add to the system. So usually it's a good idea to kind of keep it to a minimum. But on the other hand, like the more components you add, the kind of more cognitive load you split into smaller pieces, so the model has less load on this. The next stage, if you still don't get enough performance out of your model, or if you want to get lower cost, you can kind of start for fine-tuning. And a simple way to kind of collect data, no matter what your use case is by simulating basically real interactions in your app. And you do this by creating templates about how a human, like basically different roles of a human. And then you instruct one language model to act as a human, and basically the rest of your system acts as normal. And it's basically synthetic data that you can kind of use to fine-tune on. And for this, like prompt diversity and difficulty is really key. So I think one of the core issues of like alpaca models, like in the beginning, the first kind of fine-tuned models that went out there, was that the prompt difficulty was way too low. If the models learn much better, the more difficult your prompt is. So even if your task is not very difficult, I would try to add more and more conditions and more complexity, because then the model has more things to learn than just for a single question. Yeah, also another thing you can kind of try is like if you have multiple steps in your pipeline, you can, in the end, if you do fine-tune, you can distill to skip some of them. You basically have like some initial inputs and some final output, and you can directly distill a model to get these first inputs and auto-generate your final outputs. And this can increase a lot of, decrease your latency, but will kind of decrease performance a bit. When the next step that's really easy is that you kind of filter your data. So this kind of gives you, like usually with just fine-tuning, you get to like GPT-4 performance on your specific task, but you can get much further if you simply do some rejection sampling or filtering of your data. And for this, an easy way is if you don't have execution feedback in some way, is that you basically use language model judges. So just judge your output of your model, or like of a larger system, or even the final output of your system. And then basically you filter out whole swaths of your data that you know probably didn't work that well. Even if your judge is not perfect, this will kind of increase your performance a lot. Yeah. And finally, so last step that you can kind of approach is like reinforcement learning. So this even allows you to kind of optimize over multiple steps in your system. So it's especially important for agents. And good ways to get a signal for this is execution feedback, or like we said, with language model judges of different parts of your system. But I would usually consider reinforcement learning a kind of a final step when other methods don't work, because it makes it kind of difficult to move to different models, and also there's a lot of setup costs you have to do. Yeah, so I think that's it. Awesome. Thanks.